These are the state diagrams for a project. The top state table is the state table for the light bulb moving through the 4 light bulbs, or the light moving. The highlighted areas shown by the red arrows are the only states that we want to show. Everything else must go to one of those states if it was previously so. The bottom state diagram is a diagram for the blank light bulb moving through. Arrows yet again show the only states that we want to show. This is part of our truth table for our circuit. Indicated in the red box are our inputs. I is the switch, A, B, C are what the light bulbs are previously at from the toggles, which we are taking JK knots and turning them into toggle flip-flops. Next, we have what we want the state to go to next. 0, 0, 0, 0 needs to go to a 0, 0, 0, 1 for the light bulb moving across the screen, moving across the 4 LEDs. Next is what the toggle flip-flops need to do. Toggle A, for this case, does not toggle. B, C do not toggle, but the D does. D goes from 0 to 1. These are the reduced Boolean functions along with the circuits that Multisim drew for us. This allowed us to see how many ANDs and OR gates we would need, or how many input ANDs and OR gates we would need. For the first function, for toggle A, you will see in the blue box, we needed 3 2-input AND gates, and then we needed 3 input OR gates. For this, we needed at least 2 4-input AND gates, and 2 2-input AND gates, as well as a 4-input OR gate. This is the function for the C toggle. In the box it shows the most reduced Boolean expression in the circuit drawn again, courtesy of Multisim. Finally, this is the D toggle function, most reduced Boolean expression in the top, showing us how many ANDs and OR gates and how many inputs for those gates we need.
This is a rough draft of the layout for our breadboard. As you can see here, these 2 squares on the right are our JK knot flip-flops. On the left are our 2 input AND gates for our logic functions for completing the circuit. Below this is a 4-input AND gate chip on the left and a 2-input OR gate chip on the right. And below this we have more of the same. Another 4-input AND gate chip on the left and a 2-input OR gate chip on the right, followed by another set of the 2. Once again, these chips are all just to complete the logic functions to help make the circuit work. And now at the bottom of the page, we have on the left our switches, which we're only using one of for our input switch signal, either low or high, and on the right we have our inverters. 4 of which are used for the 4 JK knot flip-flops, and 1 of which is for our input. And this is what the finished sequencing circuit looks like. As you can see here, when the input is set to give a high signal, a blank light bulb will cycle from left to right, and then once the input is switched, an illuminated bulb will cycle from left to right in the same direction.